Hello, my name is Subrata Roy. Today we're going to talk about the consistent hashing. I think we all knew what is consistent hashing, but do you think it is easy to understand the consistent hashing? And when it comes actually, handy, the consistent hashing. So I think that is what we want to talk about very quick and very dirty way so that whenever you are designing the systems, especially the horizontal scaling, consistent hashing come handy for you. So before that, I just want to have a small introduction about me. Yeah, so my name is Subrata Roy. I'm working as an IT industry for more than over 15 years of right now in terms of designing and implementing strategic IT solutions, strategic cloud adoptions, and also I have derived definitely strategic IT transformations across various geography I have worked, such as India, US, UK, Europe, South Africa, and Middle East. And I have worked in majorly into the banking, insurance, mortgage, and some of the manufacturing as well as retail industry also. And also, I'm a thought leader in emerging leader technologies and best practice implementation for technology transformation, consulting, enterprise architectures, which is one of my very favorite kind of things. And while doing that, the technology transformation, I found the system design is one of the key thing, and that's where you need to quickly uh, implement or quickly come up with some sort of designing as well, some sort of address the solutions in terms of horizontal scalability, availability, security, and all. So I think in that respect, in short, this is what I would like to highlight the hashing perspective. So just to tell you again, the hashing where it can help. It can help to achieve our whenever you're thinking about from a horizontal scalability perspective. Whenever we have a distributed systems, especially the database. Uh, whenever we have a horizontal database, we are doing that in terms of scalability. So there the consistent hashing is a very important. It becomes very handy so that we can actually efficiently or uh, even across all servers efficiently we can respond to the client request or server request. So I think that is what the consistent hashing is important and hashing. So before moving to the talk about the what is hashing and all, I just want to highlight one of the problem statement. Let's understand the what problem that consistent hashing can solve. So don't think about the hashing and all this concept. I'll definitely talk about in my next slide what is hashing and all. But before that, think about your database servers which has a four servers. In terms of horizontal scaling, you already have a four servers, and indexing wide is 0 1 2 3. At this moment it has been distributed, right? Suppose you want to fetch any data, right? And how do you reach to particular servers, because it's a millions and millions of tables are actually distributed across, right? Suppose there's a 1 million, right? And you have already done that 25 some percentage of zero index, some percent of server 1, some percent of server 2, server 3, and so on. Now I want to look for some phase data now where I need to reach, right? That's what the keys are important, right? Key you are actually it's a hashing keys, so it is actually saying, okay, now anything related to key 1 and key 3, I look for a zero server 0, key 0 and key 4, I have to look for a key server 1, key 2 and key 6, I have to look for a server 2, and key 5 and key 7, server 3. So now if you look at this setting, the observation is as long as the server size or server pool or the size is fixed, I don't have any issues, right? It is fine. Okay, I want to look for a Q1, I look for a server 0, I look for a key 5, I look for a key 3, but that's not the distribution happening already happened. I don't have any issues. It's fine. Issue will come the moment I think, hey, I need to suppose remove the server 1. Now what will do? What will happen to the key 0 and key 4, right? So that's where the consistent hashing or if I want to add any more further server as a part of my scaling, then what will happen? How do you distribute those keys? That is where the consistent hashing comes and plays an important role. And yeah, so before jumping into the consistent hashing, how it works, let's understand that hashing's purpose, right? So so look at this, mod hashing that it is like we have talked about. Okay, these are keys, these are hash numbers, and it is like one, two, and there are six digit, right? And then the mod of hash mod of four, right? So before just this is just for a reading purpose. Now think about okay, key. I just introduce either key is equal to a Roy or Subrata, right? Now what has happened? This is a arbitrary length, Roy, right? Now this length with the kind of hash function, what I'll do, hash function f Roy, and then I know if I look at a mod of six, then there could be I can get a something which is a fixed at length 23. It's just a from a description aspect, from explanation it could be a 1126 to 1. The way I need to distribute, right? So what happened, that input is my arbitrary length, but the output is my fixed length, and that fixed length will help me to understand where I need to figure, where I need to look for a particular data, right? If I wanted to raise a key zero related data, so where I need to which server I need to go? I need to go for server one, right? And that's the hashing, that string, that data hash key is that digit will help me to understand where I need to go. So I mean, that is what the where it is written. The server index equal to hash key uh, a mod of n, where n is this size of the server pool. So when I say the size of the server pool, it is like we have like four server, right? 0, 1, 2, 3. So this is the size of the server. So the n is the server 4 size of the server pool. Okay, now the function is like, okay, hash key mod of 4 equal to 1, right? I need to fetch some data from a key 0 of server pool of 4 from a this server, right? So that is what I need to. So client will reach to my this servers and fetch the data. And if I want to look for a K3 key 3, not a K3, my apologies, key 3, then I will look for a server 0 or index 0 of server. And if I look for something on K5, I look for server 3. So I mean that the hashing, that 2 to 3, 2 to 5, 3 to 3 is going to help me. That's overall the hashing is works like. You have arbitrary length, and output is you are getting a fixed length, right? And the server index equal to hash of key mod n, and where is the n is the server pool size, right? Here we decide the pool size is 4, right? Yeah, so that's a very straightforward. There is nothing complexity over here. Now here comes that important thing, right? Now think about the first thing where we talked about, hey, if I remove this server, where I already distributed the keys, if I remove this server, what will happen? How this redistribution look like, right? So I have removed the server one, right? Now what will happen? The redistribution, right? K0, what is that called? K0 and K4, right? I can see that K0 is here and K4 here, and whatever is the happening was there in K2, that server 2, it is also redistributed. So entire redistribution happened just like that without any logic, right? Now what will happen in this scenario? My client will reach to, if I have some data, suppose it wants to get a K1, right? It doesn't know where it is now because entire redistribution has happened without any logics, right? Because I have removed that one server, and same thing can happen if I add one more servers as a part of my scaling exercise. So this is to avoid this thing. This is what the consistent hashing comes and play important role, special role, where this redistribution has happened logically and it is resized, right? So let's look at how the consistent hashing works, right? So how consistent hashing work? Consistent hashing works actually you need to, instead of you need to make a hash ring. So all this distribution of server, server list of servers and distribution of keys in the servers, think about it's a hashing. So this is what the beauty of the consistent hashing. So hash ring, you have a server S0, S1, S2, S3. So now your K0, K1, K2, K3, how it is allocated, how it is distributed. It is, suppose K1 is distributed with the S1, K2 is distributed with the S3, and K3, S3, and K0 with the S0. This is how the distribution happened. And then movement is also happening through clockwise, right? So if at all, if I need to find a uh, particular key, so I will move to clockwise and I'll find it, right? If I have to move for a K0 and I will move clockwise and I'll find it. So that's the hashing, how that consistent hashing works. Now think about scenario where I need to remove the server 0, right? I need to remove server 0. Suppose I have removed that server 0, and that for that purpose I do not have to do any other distribution, right? My K1, K2, K3 is all there. I do not have to worry. I only thing is I have to distribution I have to do with the K0 only. Suppose I remove S0, server 0. Similarly, if I want to add one more server also, I do not have to worry about the other keys, right? K1, K2, the redistribution things I have to worry about only the K0. So this is how the consistent hashing works. The redistribution of keys is related to particular when it is a clockwise hashing particular keys only, so you do not have to do the entire thing. Whereas you know in general hashings, we have looked into that typical distribution happens, right? We remove the given, the distribution happen across there without any logics. But here it is the redistribution, or if I adding or if I removing, it is shown only for the particular keys only. I think this is how the consistent hashing works. So though I I mean it's easy to say that this should be the way of consistent hashing work, but algorithm uh, it have some this basic approach algorithm has some limitations. One of the thing is that while this kind of distribution you were thinking, you should think that from a virtual node increases, the distribution keys become more balanced. It should not happen that S1 server, S1 node have a more number of keys and some of the other servers has a less number of keys. So that distribution should be more balanced, and so that outcome is better. So I think this is the how the consistent hashings work. And when it comes to the minimized, keys are redistributed when servers are added or removed, and it is easy to scale horizontally because data are more evenly distributed, and mitigate the hotspot key problem. Excessive access to specific shard could cause server overload, right? The moment you have excessive access to particular key server, so many keys, then there might be overload. So that is also to balanced approach. So that's why the consistent hashing is widely used in real world system, including some notable ones: partitioning component of Amazon DynamoDB, and the data partitioning across the cluster in Apache Cassandra, Discord chat application, Akamai content delivery network. I mean, these are the some of the things where consistent hashing works. I think, yeah. So that is what all about consistent hashing. I hope you are able to learn today about the consistent hashing. Thank you very much. I will come up with another video in my next segment. Thank you.